Building a multimodal large language model. Building a multimodal large language model (LLM) involves integrating different types of data inputs and outputs beyond just text. Here's a step-by-step guide to help you understand the process. 1. Understanding multimodal data. Text, traditional language data. Images, visual data, requiring image recognition and processing. Audio, speech or other sound data, necessitating speech recognition. Video, combination of visual and auditory data, more complex due to temporal aspects. 2. Data collection. Gather diverse datasets. Collect datasets that include multiple modalities. For instance, datasets like COCO for images and captions, or AudioSet for audiovisual data. Align data. Ensure that different modalities are aligned in time or context, e.g., image with its description. 3. Model architecture. Unified representation. You'll need to convert all modalities into a common representation space. This often involves encoders, separate encoders for each modality, e.g., a CNN for images, a transformer for text that convert raw data into embeddings. Fusion mechanism. Combine these embeddings. Techniques include early fusion, merge at the feature level. Late fusion, combine decisions or outputs from separate modality-specific networks. Intermediate fusion, combine at some intermediate layers. Transformer architecture, use models like Vision Transformers, VIT, for images or AdaptBERT for text, ensuring they can handle different modalities or combine them. 4. Training. Pre-training. Start with pre-training on each modality separately or together. Self-supervised learning tasks like masked language modeling for text or masked image modeling for images can be beneficial. Fine-tuning. Use multimodal tasks for fine-tuning, such as image captioning, visual question answering, VQA, or audio-visual classification. 5. Loss functions. Define loss functions that can handle multiple modalities, perhaps using a combination of loss functions for each modality or a joint loss. 6. Evaluation. Metrics. Use modality-specific metrics, BLEU for text generation, accuracy for classification, and multimodal metrics, e.g., for VQA. Benchmark datasets. Test on benchmarks like VQA v2, Flickr 30K for image text tasks. 7. Scalability and efficiency. Consider computational resources, especially for inference. Techniques like distillation or using lighter models for edge devices can be crucial. 8. Tools and libraries. Hugging Face Transformers for handling and fine-tuning transformer models. PyTorch or TensorFlow for building custom models. OpenAI's Clip for understanding how image and text can be aligned in a shared embedding space. 9. Ethical considerations and bias. Ensure your model doesn't propagate biases from one modality to another. Address fairness in data representation.
10. Deployment.
Think about how you will serve this model in a production environment, considering latency, bandwidth, and user interaction. Building a multimodal LLM is complex, requiring deep knowledge in both machine learning and the specifics of each modality you're working with. It's an active research area, so keeping up with the latest papers and techniques is essential. Remember, the effectiveness of your model will heavily depend on the quality and diversity of your training data.